Alrighty, so this is pH 111, chapter 9. So it's going to be the center of mass and linear momentum. All right, let's go ahead. You open up. Already opened up the PowerPoint from our module. So we talked about Newton's first law. Newton's first law states that the object in motion remains in motion unless acted on by a force. Motion stays in motion unless you have a force that actually slows it down, speeds it up, or stop it. And same thing, an object at rest stays at rest until you have a force that actually moves it. So now linear, we talked about that in chapter 2, linear momentum is a measure of that tendency. Now your linear momentum is going to equal to your mass times your velocity. Go ahead and write that down. So your linear momentum, your rho is going to equal your mv. Your mass times your velocity. That's your so in the absence of outside forces, the total momentum of a set objects remains the same no matter how the object interacts with one another. So let's say we have an example. Let's say we have a 40-kilogram girl running at 3 meters per second, jumps into a 10-kilogram sled that's initially at rest. How fast will she and the sled will be moving? Here's a little example of the drawing that we did. So you got the girl going the sled is actually sitting in the rest position. So let me go right ahead. Our first example. So the mass of the girl was 40 kilograms and she was running at 3 meters per second and jumps into a sled. So that's the mass of the girl. This is mass of the sled. Let's call this M1. Let's call this M2, which is going to be 10 kilograms. Sure. Yeah, 4 kilograms, 3 to 10. How fast will she in the sled will be moving? So according to this picture, M1 is our mass for the girl, V1 is her velocity. M2 is the mass of the sled, V2 is it's supposed to be V2, but it's 0. And then afterwards, it's going to be both masses multiplied by the same velocity. So your total momentum is going to be your momentum before, and then equal your momentum after. So your momentum before be the mass of the girl multiplied by the velocity of the girl that's going to equal to both masses M1, M2 multiplied by the velocity between them. We're just going to call it V2. Now you can add your mass of the sled multiplied by the velocity of the sled. But this is going to equal 0 because the sled is in the rest position. So looking at this, what we have is our final velocity, V2 is going to equal to your M1, V1, which is the velocity of the girl, divided by your masses of both M1 plus M2. So that's going to equal to your 40 times 3 divided by your 40 plus your 10. So that's going to equal to your 2.4 meters per second. Makes sense. Now, the linear momentum of an object, again, is the product of its mass and its velocity. Okay, now your mass is going to be in kilograms, velocity is going to be meters per second, so it'll be kilograms, meters per second. Go ahead and write this down. It's going to be kilograms, this is going to be meters per second, so this is going to be kilograms, meters per second. Now, I'm going to define something called the impulse. Now, the impulse of a force is the product of the average force and the time interval during which this force acts on. Now, the definition of the impulse is your force multiplied by your change in time, which we're gonna be seeing that in a little bit. So, your impulse is gonna equal to your force multiplied by delta t. So this is gonna be your impulse. Force time. Now, your force is going to be what? In newtons. Your time is going to be seconds. So this one is going to be Newton seconds for the units, how much Newton seconds. Now, so basically from Newton's second law, we define that the force is going to equal your mass times your acceleration. And we define your acceleration as your final velocity minus your initial velocity divided by your change in time for your average velocity, for your average acceleration. Same thing for your force. So for your force, do that in red. It is going to equal to your mass multiplied by your final velocity minus your mass multiplied by your initial velocity divided by your change in time. That means your change in the force multiplied by delta t is going to equal to your mass multiplied by the final velocity minus your mass multiplied by the initial velocity, which again we defined we defined f delta t from the beginning as the impulse. Okay. Now, your mass times velocity, we define that as your momentum, which is going to be, this is going to be your final momentum. And right over here, F for this one, it's going to be initial momentum. So rho I, so initial. So that's what we get. Your momentum is going to equal to your force multiplied by your change in time. So let's say we have an example on this. Rain comes down with a velocity of minus 15 meters per second and hits the roof of a car. The mass of the rain per second that strikes the roof of the car is 0.06 kilograms per second. Assuming that the rain comes to rest upon striking the car, find the average force exerted by the rain on the roof. Well, when the rain drops on the roof, is gonna have initial velocity, the final velocity for it is gonna be 0 meters per second. So, let me go right ahead. Example 2. Now we have your final velocity. We said it's going to be 0 meters per second. Now we said that let me just look at the question. The mass of the rain per second strikes the roof at 0.06 kilograms. So the mass per time is 0.06 kilograms per 1 second. And you want to find the force. Now you know again with your impulse, which is your F delta T. Again, we said it was going to be the difference of momentum. So it's going to be your delta momentum, which is going to be your momentum final minus your momentum initial, which is going to be your MV final minus MV initial. So your F delta T is going to equal to MV final minus MV initial. Well, we said that the final velocity is going to equal to 0. That means this little fellow is going to go to 0, which means that the force is going to equal to, well, your force multiplied by delta T, let me just go ahead and do this, equals to your MV initial. That means the force is going to equal to your mass over your delta T multiplied by your V initial. I don't forget the negative. So this is going to equal to, now M over delta T, we already have it as minus 0.06 kilograms per second multiplied by your initial velocity, which was, we're going to write this down, is going down to -15. So let me just write this down over here. Your initial velocity is minus 15 meters per second. So that means our initial velocity will be minus 15. So that's going to equal to 0.9 newtons. Both negatives are going to cancel out and becomes a positive. So your force is going to equal to 0.9 newtons. Perfect. Now let's define something called the center of mass. The center of mass, and we usually refer to it as COM, of a system of particles, is the point that moves as through all of the system's mass were concentrated there, and all the forces, external forces were applied there. Now, for two particles separated by a distance d, your center mass is going to be your m2 d divided by m1 plus m2. So let me go ahead and do this one. So center of mass. And again, we go with COM. Now, so for two particles that are separated by distance d, where the origin is chosen at the position of particle 1, your center of mass is going to equal to your m2 over m1 plus m2 multiplied by the distance between them. Now this one, let me just go right ahead and get this. This is for two particles separated by distance d and the origin is at particle 1. Now, if you have two particles with a different choice of origin, your center of mass is going to equal to your M1 x1 plus your M2 x2 divided by M1 plus M2. And again, your x, that's your distance. Mainly, let me go right ahead and do it over here. The center of mass is actually all your masses multiplied by the distance. So your M1 x1 plus your M2 x2 plus your M3 x3 plus whatever it is, M, I don't know, for the n, x to the n divided by your total of all your masses, which we're going to be giving big letter M. Let me go right ahead and this down. This is total of all masses, which is M1 plus M2 plus M3 plus So actually, let me just go back over here. On the first example that we have over here, this is what you have. This is the first object, the first particle is actually the origin of the second particle. So the distance of the center of mass for this one, again, is going to be your M1, M2 divided by M1 plus M2 multiplied by the distance between them, D. If your both objects is not the origin, so it'd be M1 multiplied by your first distance, X1, M2, X2, and so forth, divided by the total mass between them. So that means that your center of mass is going to equal to 1, let's take the mass out, over the total of all masses multiplied by the summation of your mx, and we used I, let's do I, xi from I equals 1 to whatever n is. Because we just end with n. So we go from I1, I2, 3, 4 until xn, x1. Now, for 3 dimensions, let me go ahead and break this down. Let's say we break this down into your x dimension, y dimension, and your z dimension. X center of mass, y center of mass, z center of mass. That means it's 1 over the x center of mass is going to equal 1 over total of all masses from, again, we said from I equals 1 to n. Mi xi. Your y axis center of mass is going to equal all 1 over all, again, total of all your masses for all your mass multiplied by the distance in the y direction for I from I equals 1 to n. Z center of mass is going to equal to 1 over m for mi zi from I equals 0 again to n. So basically, let me go right ahead and write this down. We can define the center of mass in terms of vectors as say vector R, which is your X and Y and Z for the center of mass, d1 over your mass from I equals 0 to N MI R I. Now, we also define density. Let me just write this down over here. Actually, let me just. Now we define, let me just write it over here. Define density rho as your mass per unit volume. Actually, let me get the green. Mass per unit volume. And more precise is dm over dv, which is your masses divided by your volume. So this makes your dm over your total mass is going to equal to d volume over your volume. Let me go right ahead and just separate this a little bit. Okay, now let's go ahead and use this. So basically, if we have a change in for the center of mass, that means your X center of mass is going to equal 1 over the total masses with the integration from initial to final for X dm for your change in mass. Let me just go do this for Y. Y center of mass is going to equal to 1 over m change Y dm. The center of mass is going to equal 1 over m again integration of z dz. Now, taking this one that we just derived dm over m, and let's just go ahead and plug it right over there. So let me go back to blue. So that means your center of mass, again, your dm over m is going to equal to dv over v. And again, v, this is your volume. So there's going to be 1 over your volume, integration of x dv. Same thing, let me do y center of mass is going to equal 1 over your volume, integration of y dv, and z center of mass is going to equal 1 over v, integration of z dv. And again, same thing for the forces. When we said the net force is all the masses multiplied by the acceleration, which acceleration is the center of mass acceleration. So that means 1, 2, 3. That means your net force in the x direction is going to equal to your masses multiplied by the center of mass acceleration in the x direction. Your net force in the y, this is x, y, and z plane. So the net force in the y direction is going to be all the masses multiplied by the acceleration of center mass for the y direction. And the net force for the z direction is going to equal all your masses multiplied by a center of mass and the z direction. And this is basically what we just did right now. So we worked on this integral, we just derived these a little while ago. Now, when we actually talked about a force, which is your mass times your center mass acceleration in the x, y, and the z component. And again, F net is the sum of all the external forces. Your big N, that's your total mass of all of them in the closed system. And your A center mass, that's your center mass acceleration. So going back on this, the linear momentum is defined as mass times velocity. So let me go ahead and do this one over here. So again, let me just go ahead. So we talked about this is the linear momentum, which is mass velocity. Which is basically all your masses multiplied by the center of mass velocities. So mass total, and that's your center of velocity. So if you have, let's say, a particle with mass m that's going with a velocity v, this momentum for it is going to equal to mv. Now the question is that we usually have is how much momentum something has. Much now, if something has more motion, it's basically as hard to stop. Now, to change the momentum, you have to apply the force for a certain amount of time. So basically, let me go right ahead and write this down also. Your force was, we said, is how much momentum by dt. That means to change the momentum, you need to apply the force per time, and we call that the impulse. And write this down right now over here. So you change your momentum. And equal F delta T. Again, we call this your impulse. Letter J. So that means your F equals your D momentum. Again, that's not a P, that's a rho. Divided by delta T. That means your net force or F force is gonna be your dB over your dt. Now, we defined the, let me get a different color over here, the net momentum as your first momentum plus your second momentum plus your third momentum, kind of like the mass, plus whatever it is. I mean, we use n, so let's just take n. That means there's going to be your mv1 plus your mv2 plus your mv3 plus whatever it is mvn, which is basically all your masses multiplied by the velocity of the center of mass. Well, taking this little fella and applying it right now over here, what you're gonna have? So your d, your change in momentum per time is gonna equal to, we said it's gonna be all the masses multiplied by d, v center of mass, divided by dt. And again, as a reminder that your velocity per time is going to be acceleration. So it's your mass times acceleration. So these two is going to equal to your force. That means your F net is going to equal to d momentum divided by dt. Yeah, I'm going to actually have to use this. Okay, I'm going to make it bigger just a little bit. That means the d momentum is going to equal to f dt. Let's take the integration of both sides with respect to t. So this one, you go from t initial to t final. D momentum is going to equal again from t initial, t final, f dt. And again, this is going to equal to your momentum and it's going to equal to your change of momentum. That means your impulse is going to equal to your change in momentum. That means this one, your J is going to equal to your final momentum, like we saw earlier, minus your initial momentum. So go ahead. So this one is going to equal to your integration of F delta T. And again, let me actually go and get a bit of color. If you're looking at the plane, delta px equals momentum in the x direction. That means momentum x final minus momentum final in the x direction minus momentum initial in the x direction is going to equal to your impulse. So your momentum direction is going to equal to the average force multiplied by delta t. So let's say, so basically, let's say you got a projectile and it's hitting a target. Kind of like billiards, for instance, right? Now, your momentum is going to be equal minus n delta rho. Now, if you notice, we had a negative sign over here. Let me go ahead and do this. This negative indicate that the impulse and your momentum have opposite directions. Where n, that's going to be your number of projectiles that collide at delta t. So this is going to be your number of projectiles that collide at delta t. So your impulse, and as your average no impulse, I'm sorry, your average force is how much impulse per delta t, which we define the impulse as minus n delta rho divided by your delta t. And again, your momentum, change of momentum that we have, that's going to be your mass times velocity. So this is going to equal to minus n in the projectiles multiplied by your mass multiplied by your delta v, which is your mass times your velocity, divided by your delta t. But you get these projectiles going in. If it stops, let's say you're going in a bullet, right? If it stops, your final velocity is going to be 0. But if this stop, your final velocity is going to equal to 0. That means your delta v, which is your final velocity minus your initial velocity, is going to equal 0 minus initial velocity, is going to equal to your minus initial velocity, which is minus, I'll just say minus velocity. Now, what happens if it bounces back? If they hit and they bounce back, this. Actually, get a different color. That means you change the velocity, which is your final minus your initial, is gonna be. Now, this is gonna go in with the same velocity as going back out. So your V final, you can write this down. Your V final is gonna equal to minus V initial because it's bouncing back. That means this is gonna be minus VI minus VI. It's gonna be minus your delta V is gonna equal minus 2 VI. That means your total mass which is M is gonna equal to NM. The average velocity, force is gonna equal to minus delta M over delta T delta V. We're here, NM, that's your. So let's say we talked about billiards. So let's say you have 2 billiard balls, right? Let's say you got, here's the table over here, you got M1, and you got M1 and M2. And so M1 has a velocity, which is called V1I initial. And this one's gonna be V2I, which is gonna equal 0, stationary. So this is moving. Stationary. Now, you play billiard probably. What's gonna happen when you hit the balls? Well, M1 is gonna have velocity, final, and M2 is gonna move with a final velocity. Now, from the law of conservation of momentum, your momentum before is gonna have to equal your momentum after. So your momentum before is gonna equal to your momentum after. And again, your momentum is your mass times your velocity. Just write it down. That means your M1 V1I plus M2 V2I is gonna equal to M1 V1 final plus M2 V2 final. Again, we said that your envelope is gonna be 0. So basically what we have is your M1 V1 initial is gonna equal to your M1 V1 final plus M2 V2 final. Now let's call this your momentum equation 1. And again, we can go ahead and organize it. So because we have 2 first one masses, so we can go M1 V1 initial minus V1 final is going to equal to M2 V2 final. V1 final is going to equal to M2 V2 final. We took the M1, took it over here, and we took M1 as common between them. And this is our first equation. We just rewrote it down. Now, we also talked about the law of composition energy. So it's moving, it has kinetic energy. So let me get a different color for kinetic energy. So your kinetic energy before is going to equal your kinetic energy after. So your kinetic energy before is going to equal to your kinetic energy after, which we define the kinetic energy before as mv squared over 2. So if we apply this on here, we should get the following. So you get M1 V1 initial square over 2 plus M2 V2 initial square over 2 is going to equal to M1 V1 final square over 2 plus M2 V2 final square over 2. Then again, we said the initial speed for the one that's saying at rest is going to be 0. Okay, so what do we have? We have M1 V1 initial square over 2 equals M1 V1 final square over 2 plus M2 V2 final square over 2. Now, we can actually multiply by 2, so all these 2 is going to go away. So what we have is M1 V1 initial square equals M1 V1 final square plus M2 V2 final square. Let's just organize this. So this one be M1 V1 minus M1 V1 final square is going to equal to M2 V2 final square. Now, we have a property that says if you have an A square minus B square is going to equal to A minus B multiplied by A plus B. Well, we consider this as A squared, let's consider this as B squared. And let's take the M out. So let me actually organize this. You take M1 out, what you're going to have? You're going to have V1 I squared minus V1 final square equal to M2 V2 final square. Using this property over here, so you get M1 V1 initial minus V1 final multiplied by V1 initial plus V1 final is going to equal to M2 V2 F squared. Well, we actually have a coincidence. We had M1 multiplied by V1 initial minus V1 final as, let me go ahead and get green on this, M2 V2. So we can go ahead, V2 final. Let me go ahead and actually find better than this. That's Let me get a different color, that way we would not confuse it with what we had earlier. Let me go ahead and get orange, my safe color. This is color over here. And we're gonna take it, and here it is, we're gonna substitute it right over there. So what we would have, your M2, so this one's gonna be M2 V2 F final. So your M2 V2 final multiplied by V1 initial plus V1 final is gonna equal to M2 V2 final squared. Now, solving this equation, if you solve it for V1 final, what you're gonna have? You're gonna have M1 minus M2 over M1 plus M2 multiplied by V1I. If you solve it for V2 final, what you're gonna have? You should have 2M1 over M1 plus M2 V1 initial. Actually, I'm gratified where we get this real fast. So. So you're taking this one over here, what you're gonna have? Your M1 V1I minus V1 final is gonna equal to V2 final. I'm sorry, I put on the wrong one. And that's clear. Actually, I'm looking at this is like this. Let me just go ahead and write this down on the other page so you would not get lost. So we had the equation one, the one we had before. What is that? It's right over here. M1 V1I minus V1F. Your M1 V1 initial minus V1 final is going to equal to M2 V2 final. That means your V2 final is going to equal to your M1 over M2 V1 initial minus M1 over M2 V1 final, still equation number one. And we had equation number two. which was your M2 V2 final V1I plus V1 final is going to equal M2 V2 final. This is going to be, that was our equation 2. Again, substituting these two in, right? Make sure of the equation. I actually forgot to label the equation. That's where we got lost. So the equation for the second one. Is the one we had last. So let's just label this equation 2. Let me go ahead and copy it the way it is. Okay, here's our equation 2. Let me go ahead and erase this. Okay, that's much better. That was our second equation. Now, divide equation 2 by equation 1. So basically, you get M1 times V1I minus V1F multiplied by actually copied the wrong one. So we need to copy this one. That's the right equation. Now we need to divide this one by this one. So you get M1, V1 minus V final, V1 initial. Plus V1 final divided by M1, V1 initial minus V1 final is going to equal to M2, V2 final, V2 final, which is basically your square. So we're going to do it both of them V2 finals divided by your M2 V2F. V2 final. Now let's just go ahead. One of these cancel out with one of those. Your masses cancel out, you V2 cancel out, and this one cancel out. So what you're gonna have V2 final is gonna equal to V1 initial plus V1 final, which means that V1 final is gonna equal to V2F minus V1I. And again, solving your algebra, your final velocity for the first particle will be M1 minus M2 over M1 plus M2 V1I. Your second one is going to be 2m1 over m1 plus m2 v1I. Now again, in this example, we had it as one as stationary. Now let's say we have an example that they're both moving. So let's say you have moving targets. Where, let's say you got m1 going at velocity v1 is gonna hit m2 hitting velocity v2, and you're gonna have this m1 is gonna have a final velocity v2f, and this is gonna be m2 having a final m1f, m2 final. And again, look at the kinetic energy. Your 1/2 m1 v1 initial square v squared over 2. So on v1 initial square over 2 plus m2 v2 initial square over 2 is going to equal to m1 v1 final square over 2 plus m2 v2 final square over 2. Now we can have multiply this by 2, so all your 1/2s will go away. By the way, this is m1. So this time it's a moving target. So this time v2 does not equal to 0. So, oh, hold on. This is going to be v1 initial, v2 initial, v2 final. Yeah. So you get m1 v1 initial square plus m2 v2 initial square is going to equal to m1 v1 final square plus m2 v2 final square. Now let's organize them where you get m1 v1I square minus m1 v1 final square is going to equal to m2 v2 final square minus m2 v2 initial square. Taking m1 as a factor, you get v1 initial square minus v1 final square is going to equal to m2 v2 final square minus v2 initial square. And again, using the property that we used a little while ago, where a squared minus b squared is going to equal to a minus b multiplied by a plus b. This is one, by the way. That means you got your m1 v1 initial plus v1 final times v1 initial minus v1 final using this property is going to equal to m2 v2 final plus v2 initial times this is going to be v2 final minus v2 initial. Let's call this equation number 2. Where let's just go and look for the momentum right now, where we define the momentum as mass times velocity. So the momentum before. I'm gonna get this over here. This over here. K E before is gonna equal to K after. So the momentum before is gonna be M1, V1 initial plus M2, V2 initial is gonna equal to your M1, V1 final plus M2, V2 final. Again, we call this equation number 1. That means your M1, V1 initial minus M1, V1 final is gonna equal to M2, V2 final minus M2, V2 initial. Where you get M1, V1 initial minus V1 final is gonna equal to your M2, V2 final minus V2 initial. Again, this is still equation number 1. Now let's divide again 2 over 1. So what are we gonna have? You're gonna have M1 for V1 initial. I'm having technical difficulties. Plus V1 final times V1 initial minus V1 final divided by, what that's gonna equal to? M2 V2 gonna equal to M2 V2 final plus V2 initial, V2 final minus V2 initial divided by M2 V2 final minus V2 initial. This is gonna be M1 V1 initial minus V1 final. Oof, that was a long equation. This chapter is full of math, so whoever loves math and algebra, he is in the right chapter. So you get your M1s cancel out, you get these two cancel out, M2s cancel out, and you get these two cancel out. So what do you have left? Your V1 initial plus V1 final is gonna equal to V2 final plus V2 initial. Where your V1 final is gonna equal to your V2 final plus your V2 initial minus your V1 initial. Let's just call this equation number 3. Now, so we can actually go ahead and substitute this fellow right over here with equation number 2, where we have our V1 final. Equation number 1. Here it is. We have it over here. Yeah. So let's put V1 final as this one. So we're gonna plug, let me just write this down. Equation 3 into equation 1. So your M1 V1 initial plus M2 V2 initial is gonna equal to M1 V1 final plus M2 V2 final. That means your M1 V1 initial plus M2 V2 initial is gonna equal to M1 V2 final plus V2 initial minus V1 initial plus M1 V1 final. That means M1, V1 initial plus M2, V2 initial is gonna equal to M1, V2 final plus M1, V2 initial minus M1, V1 initial plus this is supposed to be M2. Your M1 V1 initial plus M2 V2 initial is gonna equal to your M1 plus M2 V2 final plus your M1 V2 initial minus your M1 V1 initial. So your M1 V1 initial plus M2 V2 initial, and let's just take the two initial over there. So what you're gonna have minus M1 V2 initial is gonna equal to your M1 plus M2 V2 final. That means 2M1 V1 initial plus V2 initial, M2 minus M1 is gonna have to equal to M1 plus M2 V2 final. Solving for V2 final is gonna equal to 2M1 V1 initial plus V2 initial multiplied by M2 minus M1, divide the whole thing by M1 plus M2. Now, if your initial one was 0, like we just saw earlier, your V2 final is going to equal to 2M1 V1 initial divided by M1 plus M2. Well, that's interesting. Well, we had V1 F equals V2 final, V2 minus V1. Well, we can actually go ahead and we get orange. And we can get this V2 final, and we can go ahead and substitute it right over here. So let me go ahead and write this down. Your V1 final is gonna equal to V2 final plus V2I minus V1I. That means your V1 final is gonna equal to V1 final is going to equal to 2M1 V1I plus V2I for M2 minus M1 divided by your M1 plus M2 plus, that's for your V2F, V2I minus V1I initial. So V1 final is going to equal to 2M1 V1I plus V2I M2 minus M1 plus. Let's go ahead and make it all under your M1 plus M2. So you get V2I, M1 plus M2 minus V1I, M1 plus M2. Well, let's open up the parentheses a little bit, shall we? So your V1F is gonna equal to 2 M1 V1I plus M2 V2I minus V2I M1 plus M1 V2I plus M2 V2I minus M1 V1I minus M2 V1I, and again, that's divided all by M1 plus M2. Oh, well, if we notice, what do we have? We have M2 V2I, and you got M2 V2I. Okay, so you got, let me go ahead and cancel that. So you got M1, V1I, two of those. You got M1, V1I. V2I, M1s, cancel out. You got M1 V2Is. I don't know why I have. Okay. Now, so you got M2 V2I cancel out with M1. M2 V2I. Okay, so we got, let me actually get a different color. Actually, let me just take orange. So V1F is gonna equal to, you get M2 V2I, M2 V2I. So that's two M2s, V2Is. Let me go ahead and cancel those, they're already canceled. Plus we got V1I, one over here and one over there. So we can actually say your V1I, it'd be your M2 or M1 minus M2 divided by M1 plus M2. Which basically takes your V1I over here, your V1 over I over here. And then you got M1 V2 1I, these two cancel out. And you got one over here. So it'd be M1 minus M2 for V1I divided by M1 plus M2. So your one final is going to equal to 2M2 V2I plus V1I M1 minus M2 divided by M1 plus M2. Now, when V2I equals 0, when we had stationary as the first one, and you solve this, you should get V1 final is going to equal to your M1 minus M2 divided by M1 plus M2 multiplied by your V1I. That's what we had earlier. And I know this was a messy algebra math chapter, but this would actually get us to the end of chapter 9. If you have any questions, go ahead and email me at abunaem@uah.edu, or you can give me a call at 256-348-1480. Thank you.